All right, here's some different kinds of problems. This inside of the exponential function is what I'm going to use for u. So u equaling x cubed, then du will give me 3x squared dx. So again, rewriting, so I can see what I've got. Not necessary, but it can be helpful. So I see I've got x squared dx, and here's x squared dx over here. So 1/3 du is x squared dx. So this turns into e to the u, and taking out x squared dx, and I can put in 1/3 du. So I'm going to pull the 1/3 outside, and you know that the integral of e to the u is e to the u. And then I can put the x's back in. All right. Here I'm going to let u equal the inside of the exponential function again. So I'm going to let u equal sine of x. So I know that the derivative of sine is cosine, and there it is. I'm just going to rewrite it so you can clearly see it. So cosine of x dx is exactly du, and then I have e to the u, and there it is. So integral of e to the u is just e to the u plus c, and then put the x's back in. All right, so this one's a little more challenging. So here I see that I've got u in the exponent of the e, so I'm going to let u equal the square root of x, and you know that that's the same thing as saying x to the 1/2 power. So when I take the derivative of that, you decrease the exponent, so I get 1/2 x to the negative 1/2 dx. And I'm just going to rewrite that as the fraction that it is. And you know that the square x to the 1/2 power in the denominator is the square root. So if I take this original problem and just rewrite it, separating it, I see that I have e to the u, I have 1 over the square root of x dx, and that's what this is. So what I'm going to do is I'm going to multiply both sides of this by 2, so I get 2 du, and then I just get exactly 1 over the square root of x dx. So 2 du e to the u. And so bringing it over here, just taking one step so you clearly see it. So I take integral of e to the u, and that's e to the u, and then you put the x's back in. All right, so this one's getting a little trickier here. So here I want to let u equal the inside of the trig function. I see it's out here too, but I have to let u equal the inside of the function. So du, and I see chain rule happening here. So chain rule, derivative of e to the 2x is e to the 2x times 2 dx. All right, so let's rewrite and see what I've got here. So I've got sine of e to the 2x times e to the 2x dx. So I can put the u in here, but be careful not to put the u here, because remember I have to get the du in. So I have to be able to take out this e to the 2x dx to get this du in. So by looking at this, I see that if I multiply both sides by 1/2, I can take out e to the 2x dx and put in 1/2 du. So this is just the integral of sine, which is negative cosine, and then I put the x's back in. All right, so I had to be careful not to put the u in here and thinking about how to get the du back in. So this is a good hard problem, so put a little star by that to remind yourself. Okay, so now this, I am going to put u in two places. So I see that the angle inside of the secant and the tangent is e to the x. So I'm going to let u equal that e to the x. Then du is e to the x dx. Again, let me rewrite it so you can clearly see what I've got here. So I've got secant of e to the x, tangent of e to the x, and then I've got this e to the x dx, and I'll just put a dot there just to say it's separated, correct? All right, so if I start to put in the u, so I have secant of u, tangent of u. This e to the x dx has to come out to get that du in. So now I can take the integral. So you have to have a du once you put the u's back in. So you know that this is secant of u plus c, and then put the x's back in. All right, one last one here. So let u equal to the inside function, so that's e to the negative x. I see chain rule when I'm taking the derivative. So I take the derivative of negative x, which is negative 1. All right, so let's look and see what this is. So this is the same thing as saying cosine of e to the negative x times 1 over e to the x times dx, right? All right, so if I come over here, I can see I don't have a negative here, so let's multiply the negative on the other side. And then let's rewrite this e to the negative x. Isn't it 1 over e to the x? So rewriting it really can help you see that's what I have. So I can put in negative du for this 1 over root x dx. So cosine of u, and this gets replaced with negative du. So I can pull that negative on the outside, and then just worry about taking the antiderivative of cosine, which you know is sine. And then I'll put the x's back in.